Hey there, let's dive right into this explainer. We're going to explore the incredible, high-stakes tightrope walk happening inside your body right this very second, just to keep you alive. We're talking about fluid, electrolyte, and acid-base homeostasis. Now, I know that sounds super technical, but stick with me because it's literally the story of how you survive every single minute of the day. Right off the bat, let's just shatter the whole idea that fluid balance is just about, drinking water and going to the bathroom. Did you know that every single time you exhale, you're actually participating in this ultimate balancing act? It's true. You're losing water into the air right now just by breathing. It's this continuous, completely invisible process that your body carefully measures and manages 24/7.
So here's our mental map for this explainer. We're going to hit 5 key areas. First, where body water actually lives. Second, water gain versus loss. Third, the science of thirst. Fourth, the hormones managing our fluid balance. And finally, electrolytes and cell osmosis.
All right, let's kick things off with section 1, where body water lives. Think of this as the oceans inside us.
Let's start by visualizing the actual setup here. It's kind of like having multiple microscopic oceans inside your own body. Depending on your age, your gender, and fat levels, fluid makes up a massive 55 to 60% of your total body mass. Now, what's really wild is how your body splits this incredible volume. It's almost perfectly divided. 2/3 of all that water is intracellular fluid, meaning it's trapped tightly inside your cells. The remaining 1/3, that's extracellular fluid, living outside the cells. And that 1/3 of fluid outside your cells, it definitely doesn't just slosh around randomly. It is highly organized. About 80% of it is interstitial fluid. Picture that as microscopic rivers flowing between your tissue cells. The other 20% is your blood plasma. These different compartments are fiercely guarded by some very precise cellular barriers. You've got selectively permeable plasma membranes protecting the cells, while these thin, slightly leaky capillary walls divide the interstitial fluid from the blood plasma. This whole setup allows for the constant, absolutely necessary exchange of water and nutrients.
Moving right along to section 2, water gain versus loss. Let's look at this tipping scale.
So how do ordinary, everyday things like sweating, breathing, or just eating lunch throw these precise fluid levels out of whack? Well, the crucial point here is the absolute mathematical perfection of homeostasis. To keep you functioning, the volume of fluid in each compartment has to stay remarkably stable. That means every single day, the exact amount of water you take in literally must match the amount you lose. For the average adult, that magic number is right around 2,500 milliliters. Here's how that math actually plays out on a daily basis. On the gain side of the equation, we get about 1,600 milliliters from the liquids we drink, plus some from moist foods and a tiny bit of metabolic water our bodies actually synthesize internally. But on the flip side, we are constantly losing it, and sometimes through pretty unexpected avenues. I mean, sure, the kidneys excrete about 1,500 milliliters as urine, but your skin evaporates another 600 milliliters. And remember that breathing we talked about? Roughly 300 milliliters evaporates right out of our lungs as water vapor. The scale is just in constant motion.
Next up, section 3, the science of thirst. This is essentially the body's alarm system.
But what happens when that 2,500 milliliter scale tips a bit too far? Like, what happens when you're sweating buckets during a hard workout and suddenly your water loss exceeds your water gain? Well, the exact moment water loss outpaces intake, you hit dehydration. Your blood volume drops and your blood osmolarity, which is just a fancy way of saying the concentration of solutes like salt in your blood, spikes. This sparks an unbelievable chain reaction in your brain. Specifically, a region called the hypothalamus contains these osmoreceptors that literally taste or detect this thickened blood. They act as your central alarm system, firing up your thirst center.
And the body's redundancy here is just brilliant. It's not just the hypothalamus that notices you're running dry. Signals from a dry mouth, volume receptors in your heart detecting a drop in blood volume, and baroreceptors in your blood vessels sensing a drop in blood pressure, they all converge. All these signals basically scream at that thirst center in the hypothalamus to create that undeniable "I need water right now" sensation, prompting you to take a drink and rescue the balance.
Okay, section 4, hormones managing fluid balance. Let's meet the managers.
While thirst definitely prompts us to act, our bodies don't just sit around waiting for us to find a glass of water. They deploy chemical messengers to fix the imbalance automatically. First up in a rapid-fire lineup of managers is antidiuretic hormone, or ADH for short.
When those brain osmoreceptors we just talked about detect dehydration, they release ADH. It travels straight to your kidneys and effectively locks the doors. It forces the insertion of these tiny water channel proteins called aquaporin 2 into your kidney cells, making them super permeable to water. Basically, it pulls water back into your bloodstream instead of letting it escape as urine.
Our second manager is aldosterone. This one is brilliant because it leverages a fundamental rule of biology: water follows salt. When your blood pressure drops, the kidneys kickstart a process that churns out aldosterone. Aldosterone then tells the kidneys, hey, hold on to your sodium. And because water is naturally drawn to sodium through osmosis, the water automatically follows suit. It stays right there inside your body where you need it. Finally, we have ANP, or atrial natriuretic peptide. Now, this hormone works in the exact opposite way. Let's say you just chugged a massive, supersized beverage. Your blood volume shoots up so much that it literally stretches the atria of your heart. That physical stretching forces the heart to release ANP. ANP then travels down to the kidneys and commands them to dump sodium and water right into your urine. It's a pressure release valve to lower your blood volume back to normal. So let's see how this builds in a real crisis scenario. Imagine you're out in the hot sun, sweating profusely, and your blood pressure suddenly drops. Your body initiates a very precise 4-step rescue mission. The kidneys detect the drop and release an enzyme called renin. This triggers a whole cascade known as the renin-angiotensin-aldosterone pathway. Try saying that 3 times fast. Anyway, it culminates in the release of aldosterone, which, as we know, forces the kidneys to reabsorb sodium. As you can see on this flowchart, the body essentially uses sodium as an invisible tether. That initial drop in blood pressure, or even a sodium deficiency, triggers the whole chain. By utilizing aldosterone to drag sodium and consequently all that water back into the bloodstream, your body manages to raise your blood volume and blood pressure back to safety. And the crazy part? It does all of this without you having to think about it for a single second. Which brings us to Section 5, electrolytes and cell osmosis. This is where we enter the danger zone. We've talked about the big picture and our hormonal managers, but now we really need to zoom all the way down to the microscopic cellular level, because this is where things can get remarkably dangerous. The golden rule of this entire biological system is osmosis. Water is quite literally magnetized by electrolytes. The major players contributing to the osmolarity of your extracellular fluid are sodium and chloride ions. Water will constantly flow towards wherever the concentration of those dissolved solutes is highest. It's always trying to dilute them and create total equality across the cell membrane. Because of osmosis, the fluids you consume have extreme physical effects on your cells. Think about it. If you eat a super salty meal, your extracellular fluid becomes hypertonic, meaning it's absolutely packed with solutes. To balance this out, water actually rushes out of your cells, causing them to physically shrink. On the flip side, if you drink massive amounts of pure water, the extracellular fluid becomes hypertonic or heavily diluted. Water then rushes into your cells, causing them to swell up like little balloons. And this brilliantly illustrates the extreme stakes of this balancing act we've been talking about. If you consume pure water faster than your kidneys can excrete it, which, by the way, maxes out at about 15 milliliters per minute, you risk a terrifying state called water intoxication. Your extracellular fluid becomes so diluted that massive amounts of water rush into your cells. When this happens to the neurons in your brain, the swelling inside your rigid skull can lead to mental confusion, seizures, coma, and potentially even death. It's intense. That's exactly why medical rehydration always includes a pinch of electrolytes, like table salt, just to keep the fluid outside the cells from becoming dangerously hypotonic. To tie it all together, just take a look at this summary. Your body relies on an extraordinary, deeply interconnected toolkit every single second. The thirst center prompts you to add water. ADH locks down the kidneys to reduce water loss. Aldosterone reabsorbs sodium to save water. And ANP dumps sodium to get rid of excess water. Working together, they keep those invisible cellular oceans perfectly, beautifully level. So, here's a thought to leave you with. We usually just take a drink of water and move on with our day, right? But next time you sweat through a tough workout or grab a glass of water, will you be able to feel those invisible oceans shifting and balancing inside you? I really hope this explainer leaves you marveling at the microscopic, life-saving math your body is doing behind the scenes. Because every sip, every breath, and every drop of sweat is a masterful stroke in the ultimate balancing act of life.